How you doing, everyone? Greetings and welcome to episode 5 of Learning bAtari Basic. So what we're going to do in this episode again today is we're going to carry on with playfields. And what we looked at in the last episode was the ball, which is pretty much controlled by the playfield, but we looked at positioning it on screen and moving it around with the joystick. And also we looked at using the playfield to give text messages in a very simple way within a game. Now, at the very end of the episode, what we did was we looked at drawing horizontal and vertical lines on the playfield using the pfh line and pfv line commands. And I kind of messed that up a little bit because they're commands I don't use all that often myself. And there was one other thing. I should have introduced you to a simpler command just before, which is the pfpixel command. So I'm going to rectify all that now. And what we'll do in today's episode is we'll kind of wrap up everything that we've been doing with playfields. So to begin with, allow me to show you this pfpixel command that will place a pixel anywhere we want on screen within the playfield. Now, just before we begin, let me remind you that when we've been positioning sprites and all that kind of stuff on the background, we've been positioning them between 1 and 159 on the x-axis and 1 and 89 on the y-axis. The playfield has a grid that kind of sits on top of the background, and it has a smaller range of coordinates. So it goes from 0 to 31 on the x-axis and from 0 to 10, at least for how we'll be using it today, on the y-axis. So keeping that in mind, we'll have a little look at this program here. Now, as I said, this will just position one pixel on the playfield. So what we're doing is we're opening up our main loop. We're setting our playfield color here with the value of hexadecimal 22, which will give us kind of a brown color. And we're using the pfpixel command, and we're feeding it an x coordinate and a y coordinate. So 3 on the x-axis, 4 on the y-axis. And then we have 3 kind of functions that we can pass it. We can turn this pixel on using on. We can turn it off if it's already on using off. And there's also a flip function that we can use that will actually turn the pixel on if it's off and off if it's on. So that's kind of handy to use in games. And you'll see it being used as it should be really in the last example that I'll be giving in this episode. Then what we're doing is we are drawing our screen and we're looping back to main again. So just to show you very simply and quickly what this actual little program will do when it's run, is it just positions a pixel on screen at x3 and y4. So there we are. That's pretty much it. But that is how we can place individual pixels anywhere we want on screen within the playfield while we're running our program. Now, on top of that, what I would like to show you, because I kind of screwed it up in the last episode, are to kind of go over again the pfv line and pfh line commands more or less. So what I decided I'd do is to show you how flip works in that more or less. So what I've got going here is I am drawing a vertical line on screen at the very beginning of the program. So I'm doing it outside of the main loop. And I'll explain to you why in just a second. But what I'm running is the pfv line command. And here again, we feed it a value on the x-axis, a value on the y-axis, and we need to feed it a third value. As we're using pfv line to draw a vertical line, the third value that we give it will be a position to stop at on the y-axis. If we were using the pfh line command, the third value would be a position to stop at on the x-axis. So what's going to happen here, because we've turned the line on more or less, is when we run the program, we will get a line that starts from position 3, 4 and runs right the way down to position 3, 9 on the playfield grid. Inside in the main loop then, we're setting our color here again, and what I've done is I've set up a little condition that if we press the fire button, then the pfv line that we set up here before will be flipped. So what'll happen is if it's on, it'll be turned off, and if it's off, it'll be turned on. And then we're drawing the screen so that all the information is put on screen, and we're going back to the main loop. And that is more or less the reason why I've put this pfv line on outside of the main loop, because I want that line to be displayed as soon as the program launches. But then as we press fire, it'll be turned on and off and on and off. If this command was within the main loop, every time we went back to main, it'd be run again. So it'd be constantly on, irrespective of what we did with the fire button. So that's the reason that this guy here is sitting outside of the main loop. But when I run that program, what I get is I get my vertical line on screen here, and when I press fire, it should turn on and off. And it will eventually. You see? But this is kind of a problem that I came across when I was making my little Bob game. And it showed me that I really needed to learn about restraining buttons and switches when using bAtari Basic. And I'd like to use this as an opportunity to show you how to. But basically what's happening here is we set up this program so that every time we pressed fire, the flip command would be used. So this would be turned on and off and on and off. Now what we need to remember is that the Atari itself is cycling at kind of 60 cycles a second is what's happening. So when we press the fire button, to us we're only pressing it once, but to the Atari itself we're actually, if we keep it held down for a full second, we're pressing it 60 times. So this guy is being turned on and off and on and off and on and off 60 times a second. What we want to happen is that once we press the fire button, it's only counted as one press, no matter how long it's pressed for. And that's why we need to set up a restrainer. So I'll show you how that's done right now. Okay, I'll be honest with you, this fire button restrainer thing is going to be the death of me because I cannot figure out how to explain it to you easily. But anyway, what I've done here is I've set up a variable that I've called A. And within that variable, I've put the value of 1. And then we're drawing our vertical line on screen. Now we're opening up our main loop again. We're setting our brown color to the background. And down here, I've got my little fire button logical line written, I suppose, or line of code written. So what I want to happen is that the fire button is only counted as being pressed once. So let's just go through this and I'll show you. If joy 0 fire, so if the joy 0 fire button is pressed, and I've got two little ampherands here, which pretty much means and, A equals 1. So there's a condition here going on that if two things are met, if we press the joy 0 fire button and if A equals 1, then this PFV line 349 will be flipped. So two things have to happen. And directly afterwards, A is going to equal 0. So what we have going on here is we press the fire button for the first time. A equals 1. So we've got our fire button pressed and A is equaling 1. Well, then this PFV line is going to flip. And what we've done straight away is we've set A to equal 0. Now, when this cycles through again, what's going to happen is it's going to see if joy 0 fire and A equals 1, then do this again. But because A equals 0, this line of code isn't going to activate anymore. So it means one fire button press will just run this command once, and that'll be it. In the next line we have, if joy 0 fire is not pressed, then A up here will equal 1 again. So if A equals 1 and we press the fire button, this will happen. But straight away A will equal 0. And then for the next times through, while the fire button is pressed, nothing's going to happen. Once we let go of fire, we're kind of priming the fire button again, because as long as the fire button isn't pressed, A will equal 1. And then we're drawing this screen here again, and we're going back to main and running through this the whole time. Now, I'm after trying to explain this, I don't know how many times and how many takes, and that's about as good as I can explain it to you. So let me just show you how this program works when we run it. So here we are with our restrainer. Now when I press the button, we're getting it to turn on, we're getting it to turn off. And if I keep the button pressed down, there's no funny flashing going on 60 times a second. We have set up a restrainer. And that is a really, really handy little trick to know when you're writing games and whatnot using bAtari. Because when I had my little Bob program going, when you were selecting what type of game you wanted, a 1-player or a 2-player game, That was an absolute nightmare. All you had to do was touch the button and the screen was flashing wild between everything and you couldn't select the thing. So this is a very handy little trick to know, so I thought I'd slip it in there as well. Okay, so seeing as we've been looking at this whole playfield pixel command, I thought maybe a nice little practical way of showing you it is to pretty much use it to fill up the entire screen with playfield pixels and then to wipe them all out again. And the way I've done that is I've written this fairly simple little program. So we're just setting up 4 variables at the beginning. We've got X and Y, which are going to be the X and Y positions of our playfield pixels. And then we've got C, which is a little counter. And we can change that inside in the program to kind of speed up, to change the speed of how quickly the screen is filled up and erased again. And we've also got T here, which is a little flag to let the program know if it's supposed to be turning on playfield pixels or turning them off. So in our little main loop here, what we're doing is we're setting our color background to black, and we're setting our playfield color to a kind of a green color here using the hexadecimal value of D6. And straight away what I'm doing is I'm setting 2 conditions. I've got if T equals 1, then our playfield pixel X and Y will be on. And if T equals 0, then our playfield pixel XY will be off. So we're starting a program with T equaling 1, so we're going to have our pixels turned on. So we're starting with a blank screen, and as it draws these, they're going to be turned on right the way along. And this here is our code pretty much to do the whole thing. So we've got C equals C plus 1. Now C is our counter. And what's happening is if C is greater than 2, then C will equal 0. So we've got C going from 0 to 1 to 2 to 0 to 1 to 2. So it's going to take like 3 counts every time before it draws a pixel on screen. Because what I've got here is if C equals 0, then X equals X plus 1. So every time C equals 0, the value of X on the playfield will be increased by 1. And we're going to end up with a playfield block being kind of turned on. Now, if X is greater than 31, so when the value of X gets right over to the right hand side of the screen here, then X will equal 0. So it'll go back again to the left. But also what will happen is Y will equal Y plus 1. So the value of Y on the playfield's Y-axis will be increased by 1. So we'll actually move down 1 place. And also what I got going here is that if Y is greater than 10, so by the time that Y gets right down to the very bottom of the screen, if it goes to 11, then what's going to happen is Y is going to go back to 0 again. So everything is going to go up to the top of the screen here again. And also, if Y is greater than 10, then T will equal T plus 1. So the value of T will be incremented. Now T, when we start the program, is set to 1. So what's going to happen is T will change to 2. But then in my next line I have here, if T equals 2, then T equals 0. So effectively what's going to happen is T is always going to be either 1 or 0. Because if it goes to 2, it'll go straight to 0. So for the next kind of line where it starts from 0, 0, T will be 0, which means that these playfield pixels will be turned off again. And that's pretty much the logic that's going on through it. We're just increasing the playfield pixel value here on the X and the Y as we move along, and it turns on the pixels. When it gets to the bottom, T is set back to 0, and then it'll start going through again, turning off the pixels. And looking at that program running, what we get is quite simply this. It's just our screen filling up. Again, you could make it go faster by changing the thing that C is counting like from 0 to 1 and back to 0, and it'd speed it up by 1/3 again. Or you could have it go 3 times faster than it is right now if C was always 0 type thing. But this here is what's happening. T right now equals 0, so it's turning off our playfield pixels. When we get down here to the bottom again, T will go back to equaling 1, and then it'll start turning on the pixels again. But this is just like a nice little kind of example program to show how it can be used that way. And I'm sure it could be used for for anything you really wanted in a game, that kind of where you could have these guys going down that way or whatever which way you wanted, just to make a nice little pretty pattern while you were playing a game, or I don't know, moving a missile around or whatever the heck you wanted to do. Okay, so just to finish up for today, what I thought would be nice is maybe to look at a program where we can shoot missiles to destroy playfield pixels, because that kind of thing comes in very handy for a game. Now, there are a few little commands that we haven't covered here before, and there's also a little section of the code that, to be honest with you, I don't really understand. But basically, what we need to do is we need to set up a playfield. We need to put a sprite on it, and we need to have it so that when we press the fire button, that sprite will fire a missile. So we know how to do all that kind of stuff. Now, the problem kind of comes in when you remember that we have the background kind of coordinates where x is going from 1 to 159 and y is going from 1 to 89. And that's pretty much the kind of coordinates that we would put our sprites on, our missiles on, our ball on, and all that kind of stuff. Then our playfield is a different grid again, kind of superimposed on top. And that's going from 0 to 31 on the x, and it's going from 0 to 10 on the y. And we need to find a way to kind of translate the background coordinates to the playfield coordinates. I'll be honest, I don't fully understand it, but when we get to that part in the program, I'll try and explain it as best I can. Anyway, what we're going to do, first off, we're going to draw a playfield using the technique that I showed you in the last episode. So we've got our playfield, and then we're marking it out with our capital X's for the pixels we want turned on, and we've got our full stops for the pixels that are going to be turned off. Then what we're doing is we're setting up, or we're kind of defining a few variables here. I'm defining an X and Y variable for the sprite's X and Y position. I'm sticking 50 in each of those. And I'm also setting missile zeros X and Y positions to 200 so that it'll be invisible and kind of off the screen when the game starts or when the program starts. Missile zero's height is going to be set to 1, so it's just going to be a single pixel on screen, very small. And also I've set a variable R to equal 0, and we're going to be using that as a button restrainer. Now, all this is done outside of the main loop because I want that the playfield will stay destroyed as we destroy it. I don't want it to be kind of reinitialized every time the main loop is run. Inside in the main loop then, what we're doing is we're setting our color background, we're setting our sprite color, and we're also setting our playfield color. And I'm linking player 0x to the x variable that we assigned above, and player 0y to the y variable. Then we're drawing our little sprite like we did in episode 1, and we're also assigning joystick movement to him. So he'll go up, down, left and right, and also he will flip when he goes to the right hand side of the screen. Now, in episode 3, I think we looked at some at using missiles, more or less, and that's what we're doing here. Well, first of all, what we're doing is we've got it set up so that if joy 0 fire isn't pressed, R is going to equal 0. So that's priming our button restrainer, like I showed you earlier on. And here, if joy 0 fire and R equals 0, then what's going to happen is missile 0x is going to start from player 0x's position plus 4. And missile 0y is going to be player 0y minus 3. So that's how we're going to set the starting position for the missile in relation to the actual sprite. And R will equal 1, so our button restrainer, that once we press the button, it's not going to activate a load of times. And here then I have missile 0x equals missile 0x plus 2, which is going to shoot our missile right the way across to the right hand side of the screen. Now, down here is the translation part between the background and the playfield grid, like I was talking about before. And what we're doing is we're taking our missile's X position, and we're doing a little calculation and putting it into a variable A, and we're taking the missile's Y position and we're doing a calculation and putting that into the variable B. And that's all taking place here. We have A equals missile 0x minus 18, and then take that and divide it by 4. And B will equal missile 0y minus 1 and divide that by 8. And that is how we calculate the relative positions between the two grids, the background and the playfield grid. And then we have another command in here that we haven't seen before, and this is pfread. Now, pfread, we give it a value, an X and a Y value. And what it does is it checks to see if a playfield pixel is active at that location. So what's happening is if a playfield pixel is active where the missile is, then the missile will be sent to 200 on the X and 200 on the Y. So pretty much taken off screen. And also what will happen is our playfield pixel AB will be turned off. So our missile will travel along the screen. For every position it takes along the screen, its coordinates will be translated to the playfield's coordinates. And once it gets to a coordinate where there's a playfield pixel, that pixel will be turned off and the missile will be hidden. So that's pretty much what's happening there. And then finally what's been set up is that if missile naught's X position is greater than 141, so if it goes out to the edge of the playfield grid, the missile will be hidden off screen again. And equally, if the X position is less than 18, so if it goes over to the other side, the missile will be hidden off screen as well. We're drawing the screen and then we're going back to main, we're looping through the whole thing again. And that program, what it gives us when we run it, is Bob here on screen. We've got our little hedgehog and we can move him around. And when we shoot our missile, it destroys any playfield pixels that it comes into contact with. So that's pretty much what's happening. The missile is being shot from the sprite's position like we told it to be, and all these calculations are being done the whole time and turning off pixels when they are hit. And that is pretty much that. And that is it for today's episode as well, because it's getting very hot down here in this basement and I've kind of had enough for the moment. So what we're going to do is in the next episode, quite possibly, I'm not sure exactly what we're going to look at, but there's sound that we can look at, or maybe we might look at, I don't know, some other parts of logic in programs or something like that. We'll cover something fairly decent that'll be useful anyway. So until then, I will say goodbye to you and we'll talk to you next time. See ya. Bye bye.